This is problem number 2 for assessment number 8. It says the plane shown in the figure is taking an aerial photograph with a camera lens that has an angular coverage of 70 degrees. So that means that this plane's flying and it's taking a photograph, and the width of this photograph, what its coverage is essentially 70 degrees coming off of that plane. So it's covering this ground area, which is about 70 degrees wide. The ground below is inclined at 5 degrees. So we got a little bit of a hill here, 5-degree incline. So this line here represents the hill, and I'm actually going to draw that line in orange. So you can see that's the line, that's actually the ground that we're looking at. If the angle of elevation of the plane at B is 50 degrees and distance BC is 3,500 feet, estimate the ground distance AB to the nearest foot that will appear in the picture. So they want us to find this ground distance here. They tell us that we're 3,500 feet, the plane is from point B, and that the angle from basically the x-axis to this distance between point B and the plane is 50 degrees. But we know that also this hill is a 5-degree incline. So what does that mean about the actual degree from the ground to the plane? Well, let's take a look. If I draw another triangle, and I label it B, A, and C, obviously C is where the plane is. This would be little c side, or the AB side, right? This would be the little b side, and this would be the little a side. Now we know that this is 3,500 feet. We know that this is 70 degrees, but this is not 50 degrees because remember AB is the actual ground. That angle is 50 degrees here all the way to a x-axis, and then the ground is lifted 5 degrees. So my angle B is actually equal to 50 degrees minus 5 degrees, which is 45 degrees. So this angle here is 45 degrees. Now once I have this angle, I need to either use law of cosines or law of sines to figure this out. If we look at the law of cosines and the law of sines, we can easily see which one we probably want to use first. So law of cosines requires you to have at least 2 sides for this problem. We only have 1 side. So that kind of throws law of cosines out the window. Now law of sines, it either requires 2 angles or 2 side lengths. In this case, we have a couple of angles, but it requires a specific angle. It requires a specific angle that is across from the one of the legs that you know, one of the distances you know. So we really need this angle here, angle A. But we can find angle A by taking angle A, we know is going to be 180 degrees, minus 70 degrees, minus 45. So if we do 180 minus 70 minus 45, I believe that gives you, 65. We can double check that. 65 and 45 gives you 110 plus a 70. Yeah, that's right. So this is 65 degrees. Now I have angle A and side A, so I can use A sine A, and then I can obviously use C and sine C and C to find this length AB, which is what we were looking for. So let's say that is, little side A is 3,500 over sine of the angle, which is sine 65, equals B over sine 45, or not B over sine 45, sorry, C over sine 70, because we're looking for AB. So C over sine 70 degrees. So we want to multiply sine 70 over, so that's 3,500 sine 70 over sine 65 equals C, which means that C equals this 3,500 sine 70 over sine 65. Now, when you go to put this in the calculator, you got to make sure that you are in degree mode. So when I'm looking at my calculator, I look at the top, I see I'm in degree mode, so I'm good. I don't want to be in radian mode here. So I'm going to go ahead and type in 3,500 sine 70 divided by sine 65, and I get 3,629. Well, let's go 28.9 in case they want us to round to a tenth, and that's feet. And this is for the AB. Remember, AB is C, which is this 3628.9 feet. So the amount of coverage on the ground that I'm getting when I take this photograph is actually 3,628 feet.